This session we're going to look at the assembly importer. It's actually gone by a few different names. It was called the CSharp class importer, I think, at one point. Currently it's called the .NET DLL importer, but it's all the same thing. If you've been following some of my lectures in the past, I've talked about using callable wrappers to be able to use .NET assemblies in PowerBuilder. The assembly importer gives us another way to do that. Not use callable wrappers, but another way of using .NET assemblies in PowerBuilder that's probably a little bit easier for most people to use than the callable wrapper approach. So first of all, we have the standard legal disclaimer. Let's look at the agenda. I'm going to talk about myself for a little bit, just in case you may not be familiar with who I am. Then I'm going to talk about the importer. We'll actually go through the process of how you import an assembly. We'll talk about the CSharp assembly class, which is the main class that's used internally to the generated objects to handle the .NET assembly import. We'll talk about how you do debugging when you have imported your .NET assembly. We'll talk about some of the extra files you'll need to deploy with your application if you're going to be using the assembly importer. And then I've got a few demos. So first, a little bit about me. I've been doing PowerBuilder development actually for quite some time. I'm currently working for a company called Integrated Data Services. I've been with them since 2004. When I originally started with them, they were basically a client-server shop based entirely on PowerBuilder. We've since moved on to HTML5 and JavaScript for client side, Java in the middle tier for most of our projects, but we do have a few PowerBuilder clients still. But before going to work for Integrated Data Services, I spent 15 years as an independent contractor doing PowerBuilder development. In addition to PowerBuilder, I know Oracle PL/SQL, Java, C#, C++, a few other things. And I'm involved in a number of open source projects. For example, the open source PFC libraries. I help maintain that. I did a utility called PBNI SMTP. It's for sending email from PowerBuilder. It's based on the PowerBuilder native interface, so it's a C++ extension for PowerBuilder. And then I've got a Jenkins plugin, and a number of plugins, but the Jenkins plugin for the autocompiler is probably the most useful one to PowerBuilder developers. So it uses the autocompile utility to do PowerBuilder 2017 and 2019 compiles from Jenkins. So if you want to get into continuous integration, use Jenkins to automatically do builds for you, you might want to look at something like that plugin. Enough about me, a little something about the company I work for. And let's get directly into the assembly importer. So the assembly importer supports a great number of data types because C#'s a little bit more modern language than PowerScript. Its data types are larger than the PowerBuilder data types, and so you'll see that an integer in PowerBuilder becomes a short in C#, whereas a integer in C# is a long in PowerBuilder. So so just be aware of the data type, the data size differences between the two languages. Some of the stuff is directly equivalent. Doubles are the same, decimals are the same. There's string types, the char and the string are pretty much the same. Then there are bytes, booleans are the same. Blob in PowerBuilder becomes a byte array in C#. And then C# only has a date-time data type. It doesn't have separate date and time data types. So if you have a date, a time, or a date time in PowerBuilder, it will be a date time in C#. And then if you wanted to share an ADO data connection between PowerBuilder and the assembly, that can be done using the ADO connection proxy object. A couple things to note. In C#, arrays are 0 indexed. That means the first element is element 0 and the second element is element 1. Many modern languages have that. Java is the same way. Or obviously in PowerBuilder, PowerBuilder uses a 1 based index for arrays. So the first element's 1 and the second element's 2. Just need to be aware of that, if particularly if you're writing the C# code as well as the PowerBuilder code, and that you don't bring PowerScript syntax into C# and create an array that starts with 1, because what will happen is when you pass that array to PowerBuilder, then that first element will be null when you're actually expecting data in it. Also, I mentioned that IADO connection proxy object. That is a PowerBuilder.NET class, but it's only supported in the .NET framework, not in .NET Core. So you'll need to write, if you're going to have an assembly that uses that that shared database connection, you have to write it in a .NET framework, not .NET Core. PowerBuilder doesn't support functions that return arrays. And the reason this becomes an issue is you can have a C# method you're calling that does return an array. Now, that doesn't mean PowerBuilder is not going to handle it. What it does mean is it's going to map the return type of the function to an any data type, and then you're going to have to cast that into the appropriate array type. And in one of my demos, I show you how that's done. Okay, now here's some of the issues we're going to get into. As with the callable wrappers, if you've attended any of my sessions on that, you'll remember there were a lot of limitations in what you could do with a callable wrapper, because the interface didn't support a lot of the modern language constructs that are supported in C#. And the same is true with the proxy classes you'll be creating using the assembly importer, because we're going to be constrained to what PowerBuilder actually supports. So since PowerBuilder doesn't have things like interfaces or static classes, when those exist in the C# assembly, PowerBuilder, the assembly importer, is not going to be able to do anything with them, because there's no equivalent in PowerScript. So interfaces, structs, static classes, abstract classes, and generic classes aren't supported. What you'll see when you run the assembly importer is that it will show you what methods and what properties and what objects and what classes it can support, and I'll show you which ones it can't support. So that may become a limiting factor. In addition, static, protected, private, internal, generic, and extension class members are not supported. It does support, the assembly importer does support nested classes, but instead of using dot notation, you actually use a plus mark between the parent object and the nested class. Functions that take generic or delegate classes as arguments or return values are not supported. Optional arguments are not supported. Functions that take a variable number of arguments using the params keyword are not supported. And passing arguments by reference to a constructor function is not supported. You can pass arguments to a constructor function. As we'll see when we dive into it a little bit, one of the methods on the C# assembly class is the create instance call, and that allows you to pass in arguments to the constructor. Next, we'll look at properties. Now, so for every property that's in the .NET class that you're importing, PowerBuilder, the assembly importer, creates a getter and setter function for it. Only the top level properties are supported. You can't do dot notation into, if you had a property that was a class, and of course that class had properties of its own, you couldn't access those properties of that object that's also a property. You can only do top level properties. And then properties of a generic, delegate, or question mark class are not supported. And this kind of makes sense. So private or protected properties are not supported. It has to be public for you to access it. And indexed properties are not supported. And then data fields are not supported at all. So what that means is it's going to be a little hit and miss when you go to use your assembly. You might, one of my samples, I was trying to do SMTP, and I tried a number of different libraries, and I couldn't find. Well, I tried 3, and none of the 3 would import well enough because of these limitations we've covered for me to use directly. And so, as we'll see when we get into the demos, I created a wrapper class that called one of the libraries I ended up using called MailKit, and in my wrapper assembly, I made sure that my functions and my data types were all compatible with PowerBuilder, so that the assembly importer could import it without any issues. So there's an option when you use the assembly importer to auto-generate scripts, and these auto-generated scripts then use this C# assembly class in PowerBuilder to create the objects and do all the interaction they need to do with the for the methods and the properties. If you don't want to use the auto-generated scripts, or if you want to modify them, then it's important to know what this C# assembly class is doing. Most of the time, you probably could just run the importer, use the auto-generated scripts, and not care about the C# assembly class. But down the road, when you get doing more advanced stuff, that might be something you would need to know about. So one of the important functions of the C# assembly class is that create instance method I referenced earlier, and that's how you can pass arguments into a constructor function, which is something that PowerBuilder doesn't do out of the box. So when you create an object in PowerBuilder, there's no constructor function. Well, the only constructor function there is doesn't take arguments. So the proxy object can't look like that. And so what you do internally is use this create instance call to pass the arguments you want within your proxy object. There's a couple other functions here. There's the load with .NET Framework and the load with .NET Core. Now this is called internally to your proxy classes to load the assembly that they're doing the proxy for, and so it takes a string, which is the path to the assembly. It can be relative or absolute. Generally, what you would do is you would take the assembly that you're proxying and deploy it with your application, either in the application directory itself or a subdirectory of the application directory, and then you would use a relative reference to load it. The difference between these two just depends on whether or not your assembly was written to use the .NET Core or the .NET Framework, and you would use the appropriate function then. And then there's an error text property, which if any of those functions returns anything other than a 1, contains the text of the error message telling you what went wrong. Okay, so this is how you get to importing an assembly. There's a couple different paths you can go through. If you go to the Tools menu, you'll see there's this .NET DLL importer, and you can use that. Or if you go File New, then the new dialog comes up, and you click on the Tools tab. The .NET DLL importer shows up there. Either way, once you get there, you get to a dialog. This is a piece of the dialog. I've got another slide here later where I show you the entire dialog. But what I wanted to show you here, under the advanced settings, this is where you get the auto scripting. So make sure that you've checked that, and the assembly importer will wire everything for you so that you've got classes that you can immediately use. That's assuming you can actually import the assembly that you need. So there's a bunch of different methods that get generated on these proxy classes, and there's a number of fields as well, or properties I should say. The main one you're going to look at here that you want to make sure you use in your code is this offset error handler. What that does is that if when you're running your application, if there's an exception in the .NET assembly, what will happen is the proxy class then will look to see if it's got an error handler, and if it does, it will call an event on the error handler, basically saying I've got an exception here. So what you pass in here is the name of the PowerBuilder object that's going to be receiving that event, and then the name of the event you want it to call. And I'll show you in the demo we do here in a bit how that works and how you can use that to handle the error handling. But here you have your properties, and a couple things on the properties that for your proxy objects is that error information that you're then going to want to pull up in your error handler, or look at least in your error handler, to deal with the error in the .NET assembly. Here's debugging. So this is a new option in the system options, and so if that's checked, it will launch Snap Develop to allow you to debug your C# assembly that you've imported. Now, in order to do that with a third-party library, you're going to have the debug version of the assembly. So that's something you need to be aware of. If you created it yourself with Snap Develop, no problem. You already have what you need to debug the assembly. And then runtime deployment. There's a few additional runtime DLLs that we need to deploy if we're going to use the .NET Assembly Porter. There's the PBC Sharp 190, PBC Sharp Core Invoker, PBC Sharp Net Invoker, and then any assembly, the assembly that you're actually calling, obviously, and any assemblies that it's dependent on also have to be deployed or available on the system that you're deploying to. So we're going to look at some demos. Now, first I'm going to do, before we actually show you the demos in PowerBuilder, is kind of walk through what they do. So as I mentioned earlier, because of limitations in class support, a lot of the .NET assemblies that I tried to use for sending SMTP mail didn't really import well. And I ended up writing a wrapper assembly for it. Just a note here, there was an SMTP class in the .NET framework. Microsoft has actually deprecated that, and they recommend MailKit, and that's actually what I ended up using. I ended up using this open source library called MailKit. So what I did is I created a C# project. I decided to use the .NET Standard to create a class library. That's a little hard to read, but in Snap Development, just like any modern C# IDE, there is a utility called Nougat, N-U-G-E-T. What that does is it accesses these repositories of open source libraries. And what should be showing there is MailKit, is the library that I'm going to use for this first demo. What's really nice about Nougat is it knows what the dependencies are for MailKit. So as soon as you select MailKit and hit install, it not only automatically installs the MailKit libraries into your project, it installs all of the libraries that MailKit's dependent on. So you don't have to go around looking for all these other libraries and including them in your project. It's all automatic. Of course, when you go to do your deployment, you need to figure out what those libraries are, and we'll cover that when we're going through the demo. So I'm going to create a C# class. Now, what I've done in my C# class is we got properties here for the email and password and username for the user who's sending the email, the subject and the body of the email message I'm sending, and then I have a more complex data type that represents who I'm sending the email to. That looks like this, and basically it just has two properties, an address and a name. Now, remember, one of the limitations of the assembly importer is I can't pass an object into a function. So what I'm going to do is I'm going to create a helper function here where I send in the name and address, and it creates the mail recipient and adds it to the my class. So now PowerBuilder can call this, and it's passing simple data types. And this is the rest of the code for sending the email. This sample code and the sample code for the two other demos I have are all on the Appeon website in the code exchange section. So I'm not going to go spend a whole lot of time looking at the code here, except to note that I'm calling Gmail. I'm sending SMTP via Gmail. But you can go grab those code samples. It'll have both the PowerBuilder code and the CSharp code, and that way you can pursue, browse it on at your leisure. So I'm going to run the .NET importer. Now, one thing, this is that whole dialog, and one thing I'll warn you about, it drives me a little bit nuts, is, if you're only working, if your workspace only has one target in it, this isn't an issue. But when I was putting these demos together, I've got like 20 targets in my workspace. And whenever I fire off this .NET importer, it doesn't matter what the currently active target is. This importer will always default to, right here, to the first target that's in your workspace. And so what you need to do is you need to make sure this actually gets changed to the target that you want the proxy classes to be put in. So enough said about that, I guess. So use this browse button to go and find the .NET assembly that you want to create the proxies for. Indicate whether or not it's .NET Core or .NET Framework. In this case, it's .NET Framework. There's some options here about how you want to create prefixes for the non-visual objects that get created, and for the methods involved, whether or not you want to and add an OF underscore prefix to them, so it looks a little bit more PowerScript-ish, if you will. And then the prefixes that are put on the getter and setter methods that are created. And then there's that option right there for the automatically generating the script that wires all of it together. So here's all this is my library. Notice that I'm not importing the mail recipient class, because I'm not going to be using that within the PowerScript code. That's used internally within the assembly. So if there were problems, there would be another option down here where you could select it, and it would show you the stuff that it wasn't able to import. Because I wrote this wrapper to be directly importable into PowerBuilder, though, that didn't happen. So here's an example. Remember, if you saw the sample, earlier sample, and happened to notice, the class was called Mail Client, and so there was an option there to stick NVO underscore as the prefix, and so that's what happened. The non-visual object is called NVO underscore mail client. Also, the options were set to put OF underscore in the methods. So there are two main methods here. Some of these are generated for every object, but the ones that are specific to this assembly are set recipient. That was that wrap. Oh, sorry, I didn't mean to actually click that. The set recipient, remember, so I could pass in the simple data types, and the send mail. Okay, these ones where it says OF set underscore, OF underscore set underscore, those are the set properties. Remember that the in the C# code, the body, the password, the subject, user email, those are all properties of the class. So those are properties. I just happen to use the word set in my method name. So this underscore OF underscore set, but no underscore there. This is just the OF prefix on my set recipient method. So this is a method. These are all properties. That's a method. And then so that's what you get as a result. And then we're going to be looking at what we need to do at runtime to deploy this. When we deploy this to the client, So this isn't a very creative title. I just called my assembly demo. But so that's what got imported. That's dependent on MailKit, because that's the actual class we're using internally. MailKit in turn is dependent on MimeKit, Bouncy Castle Crypto, and System Text Encoding code pages. So all of these files, in addition to the assembly demo file, will need to be deployed to the client when you distribute your application. And then we'll go through the PowerBuilder. So that's just an example of what this looks like running. So I've got a from, a to, and a password, and then the message, text, and body. You hit send, it sends off the email. Okay, but this is what I was mentioning earlier about registering an error handler. So in this case, this is on the window that we just saw. What I'm going to do is I'm going to create a custom event called assembly error, and then I'm going to use in the create. This is the open script for the window. What I've done is I've created a instance variable. I've declared an instance variable of the mail client, so that I can reference it in that event, and in the button where I actually call this. But in my open event, I'm going to create the non-visual object, and then I'm going to call this OFSet error handler. So it's calling the window. It's telling it that if there's an error, then send the event to this window and call this event to let the PowerBuilder know that there was a .NET exception. And then this is the assembly error event. So it doesn't take any arguments, doesn't return any. But what I'm going to do is I'm going to grab the error text off the instance variable to indicate what the .NET assembly error was, and pass that along to the user. And you can do whatever you want in that script, but that's what I happen to be doing. This is the PowerScript code that actually sends the email then. So once again, these are the properties, the offset underscore, and then the property name. Those are all properties. That is a method that's passing in the information about the recipient. And then this is another method of the assembly that actually sends the email. Okay, so that's the first demo, and we'll get to the PowerBuilder in just a minute. But let me just real quickly cover the other two demos, and then we'll go look at the PowerBuilder. So you remember I said that PowerBuilder functions can't take arrays back as the return values, or it doesn't support that. But what the importer does is it handles it as an any data type, which you would then need to cast into the appropriate array type. So in this case, I put just up together a real simple library that basically creates this static array of strings and returns it, as a string array. So this is the PowerScript code that ends up calling that once we've imported that. So once again, we've got that OF underscore prefix that's put on the method name, return array. Notice that returns an any data type. Okay. Now we have our string array, and we just assign the any data type to the string array. Now, and then what's at that point? Now we can loop through. Remember, once again, I said CSharp is 0 indexed. So my first variable, my first element, I should say, in this array is element 0, and then 1, 2, 3, 4. When we get to now the PowerScript, we start with 1. Okay, because what's 0 in C# is 1 in PowerBuilder. So this will just show the data coming out from that array. The minor issue here is that this code is somewhat brittle. This declaration, or this assignment, I should say. If you decided that you were going to change this function in your assembly, it would be possible to change it so it returns something different, like an integer or long or something else. And this code would continue to compile, because at compile time, PowerScript can't tell what this assembly is actually going to return. So it's going to assume that casting an any data type to a string array is still valid. And what will happen is at runtime, if you've just decided to change this to longs or something, that assignment will fail, and then this code will crash. So that's something just to be aware of. And then finally, my third demo, I mentioned that structs are not supported, and passing object types into functions are not supported, which is somewhat limiting. But this is a way that you can handle that, so that you can pass complex data into a .NET assembly. The way I'm doing that here is I'm taking the complex data and converting it to JSON. So PowerBuilder takes the data, converts it to JSON, passes it into the .NET assembly, and the .NET assembly then deserializes that data back into the complex type. And the inverse is, if it wants to pass a complex type to PowerBuilder, it serializes the object as JSON and then sends the JSON back. And then PowerBuilder can then take the JSON and convert it back into the complex type. So it's actually really simple to do here in C#, because there are JSON libraries that do just direct deserialization and serialization of JSON into objects and vice versa. So this assembly, then this is the complex object down here. So it's got 3 elements: a string value, an integer value, and a datetime value. But so it's basically essentially one-line calls here in our assembly. It gets a little bit more complex on the PowerScript side. PowerScript doesn't have the reflection capability that C# does. If I passed in a generic object to a PowerScript method, I can look at that object and I can see what the names of attributes on it are. What I can't do in PowerScript, though, is I can't get the values of those attributes from the object that was passed in. And so that's the somewhat limiting factor here in PowerScript, is we can't get those values off a generic object through reflection. So what I've had to do here instead, what that means is I can't do the one-line deserialize, serialize that C# can do with the JSON. I've got to do something a little bit more basically hand-coded here. So here's my complex object, which has a string value, int value, and data type value. Now, the assumption here is that I've been using this class internally to do a bunch of different stuff, and now I want to pass it off to the .NET assembly. And so I'm going to create a JSON generator. I'm going to create the JSON object. I'm going to pull the different values off the JSON object, off the complex object, adding them to the JSON generator, and then I'm going to grab the JSON out of the JSON generator. And then we'll pass that into the assembly. And then conversely, what we're going to do here is we're going to ask that JSON assembly for the complex data, and it's going to give it to us in JSON because it serialized it into JSON. I'm going to create a JSON parser, load the JSON, and then pull off each of the individual values and assign it to my complex object, and then I would go off and do whatever I needed to do in PowerScript with that complex object. Okay. Before I finish up here, I did promise I was going to show you the demos, so we're actually going to look at them running now. And so here's the PowerBuilder samples. Just as a reminder, the first one is where I've created a wrapper assembly around MailKit to do SMTP emails. So once again, this is the send mail function where I'm pulling off the attributes, the data elements from the data window, and send them into the properties on the assembly class, and except in this case where I'm actually calling that wrapper function, and then the function actually sends the email. Nothing too dramatic here. I'm sending the email to my private domain account, and just kind of flash that on there for a second so you can see what mail I had in my inbox. But I'm sending email from my Gmail account to an email account I have in my own private domain. So it says it sent it, and we'll give it a couple. Yeah, bling. I don't know if you heard that, but that was the email coming in right there from Gmail. So that's doing what it's supposed to do. Okay, this is the one. This is where I have the done an assembly that returns an array. So this is my wrapper, the class that returns the array. Here's the function. But none of these are just the standard functions that are generated for every a wrapper class. But the one here we're interested in is the return array. Notice it returns in any data type. And so here in our code, we call that method and return the data to the any, and then cast the any to the string, and then loop through the string. And once again, in the C# class, the first element's 0. Here, the first element's 1, but it's always both of them refer to the first element because PowerBuilder's 1 indexed, C# is 0 indexed. We go ahead and run that, and it just loops through all the elements. So this is the data that we got from the C# assembly. And then lastly, I've got one here. This is the one where we're doing the complex data type. And so what I'm going to do, actually it's on functions here. So what I'm going to do, and this is the same code you saw on the slide, but I've got some complex type. I pull off the attributes, I convert it into JSON, send it into the assembly, and then for the out, I get the JSON that the assembly creates by serializing the object into JSON and use the JSON parser to parse out the elements. So if we run that, I just pop up in here an example of the JSON that was generated for my complex type, and then in this one I've taken the complex type back out from the assembly and then parsed it back into the complex type and then displaying that. So as I believe I mentioned during the slides, all this sample code is available on the Appeon community website. Actually, we can go back to that slide. Okay, here at community.appeon.com. So I think most people know this because of the question and answer area there, but there's a number of other things there as well. Blog articles. I've got a number of blog articles on there, and there's a whole bunch of code samples, including the code sample for this session. So I'd encourage you to check that out as well. Thank you for your attention, and I hope you enjoy the rest of Elevate 2020.